We are moving past the era of isolated, one-off chatbot interactions. Today's AI operates as an integrated, steerable intelligence engine. To use Claude effectively, we have to examine its core mechanics. Underneath the interface, the system is governed by an architecture known as constitutional AI. This framework strictly controls the system's outputs. It ensures Claude operates according to three primary principles: remaining helpful, harmless, and honest, while actively avoiding toxic or unethical generation. In this breakdown, we will map Claude's precise operational pipeline. We will trace the path from baseline token ingestion in the cloud all the way down to local, multi-agent workflows running on your desktop. Relying strictly on basic prompt engineering falls short when you transition to complex analytical and engineering tasks. To accurately leverage this system, you need to understand its exact specifications, its execution limits, and the computational trade-offs of the environment you choose to work in. Moving from a cloud-based text model to an autonomous agent running locally shifts the security boundaries and operational rules that dictate exactly what the system can and cannot touch. This diagram illustrates the context window. This is the primary structural constraint on how much data Claude can ingest at one time. The active baseline capacity holds 200,000 tokens. That equates to roughly 500 pages of text processed in a single instance. This data intake supports standard text formats like PDF, docx, CSV, and TXT, alongside visual inputs like PNG and JPEG image files. Upgrading to premium tiers unlocks a significantly larger capacity, expanding that processing block to a 1 million token limit. Pushing 1 million tokens expands the scope of document review and codebase analysis, allowing the model to consider entire repositories of code in a single, unbroken workflow. Once the data is ingested, it moves into Claude's hybrid architecture, which offers two distinct processing routes. The direct path utilizes the Sonnet model. This is engineered for standard queries and near-instant processing. The looped path relies on the Opus model and a dedicated feature called extended thinking. Extended thinking actively forces the model to work through complex mathematical or strategic problems using step-by-step logical routing rather than generating an immediate answer. Selecting the straight path versus the looped path directly determines the computational overhead and the latency of your task. You optimize for either speed or deep systemic reasoning. Managing these inputs effectively requires what the 4D framework for AI fluency calls description, the ability to clearly define outputs and guide the AI's behavior. Manually typing out your role, project objectives, and formatting constraints at the start of every single prompt is highly inefficient. This flowchart shows how Claude solves this using persistent state mechanics and custom preferences. The memory function automatically extracts and stores key context from your ongoing conversations, retaining details about your role, past decisions, and preferred working style. This accumulated memory state syncs securely across web, mobile, and desktop applications, maintaining an unbroken line of context wherever you log in. You can also lock in specific styles, choosing concise, formal, or highly customized communication rules, which then strictly dictate the output behavior system-wide. By preserving these memory and style parameters, the system evolves from a stateless query interface into a contextual working partner that retains your project history. This diagram illustrates the local desktop architecture. It partitions the application into three distinct modes of operation: chat, Cowork, and code. The chat layer operates much like the web interface, but with native local hooks, including a quick entry overlay triggered by double-tapping the Option key. It also enables precise screen capture mapping, so Claude sees exactly what you are looking at, voice dictation, and desktop connectors for local file access. The Cowork environment operates differently. It functions as an agentic workspace designed to execute complex, multi-step goals. When assigned a broad research or analysis task, Cowork breaks it down and spins up separate subagents that process distinct pieces of the workload simultaneously. Once the parallel processing is complete, the main system coordinates the isolated findings and compiles them into a single cohesive deliverable. To retrieve the data for these tasks, Cowork follows a strict vertical priority queue. First, it looks for active connectors, which securely pull in data from your connected internal tools and local resources. If the answer isn't there, it escalates to the second tier, utilizing a Chrome integration to navigate web pages and scrape external sites directly. The final tier is computer use. Available on high-end macOS plans, this allows Claude to take direct control of your screen to click, type, and manipulate applications just like a human operator. Because Cowork has this level of autonomy, it is contained within a rigid security perimeter. It can only read and edit files inside the specific folders you explicitly share. This containment ensures that the system can orchestrate these powerful subagents without risking unauthorized modification of your broader local file system. The third operational block, Claude Code, bypasses this sandbox completely. It functions as a full development environment, granting the AI unsandboxed access to your local file system and direct terminal execution. You can execute this either locally on your machine or connect it remotely to a GitHub repository to run tasks in the cloud. Because Code has high-level system access, you manage its autonomy using 3 specific execution toggles. In Ask mode, Claude proposes every single code change. You must manually review a visual diff and approve the action before it alters any files. Code mode applies those file changes automatically, but it will still pause and wait for your explicit permission before running any terminal commands. Plan mode steps back entirely, generating a strategic architectural outline of the approach before a single line of code is touched. When you grant an agent direct manipulation of your codebase, these granular permission modes are exactly what prevent catastrophic build errors and system failures. This matrix shows the complete architecture, a bifurcated ecosystem. Cloud integrations sit on one side, while the rigorous local desktop trinity occupies the other. The operational strategy maps neatly. You use chat for iterative drafting, Cowork for orchestrating parallel document synthesis, and Code for direct software development. Navigating this ecosystem requires the final AI fluency competency, discernment. You have to actively evaluate the system's performance. You achieve this by running systematic evaluations. You collect 5 to 10 examples of your standard workload, generate outputs with Claude, and rigorously compare the results against your baseline. Mastering an agentic system requires systematically calibrating its full architecture against the specific boundaries of your daily engineering workflows.